Okay, good morning or afternoon. I guess it depends on when you're going to watch this video. It's Melissa, your math teacher, and I wanted to do a little bit today on section 6.3, which is the least common multiple section in your book. And the reason for this is because this is a really critical section for you to learn in order to be able to do the rest of the chapter. So I'm not going to give you, obviously I have to keep this to 10 minutes, so I'm not going to give you the full lecture that I give in class, but this sentence is really important when you're talking about least common multiples. LCM is the abbreviation for least common multiple. And the way that I teach this is the way to find the LCM is to, first of all, factor the expressions that you're working with. Okay. And then once you have the expressions fully factored, you're going to use each factor the greatest number of times it occurs in any one factorization. And let's write that down because it's important for you to understand that. So then we're going to use each factor the greatest number of times it occurs in any one factorization. Okay, and then the LCM is the product. It's the product of those factors. Okay, so it's important for us to understand that. Let's take a look at a couple of problems. This is number 4 from the book. They give you these two numbers right here, 12 and 18, and they ask you to find the LCM. So when we're just working with just numbers, what we want to do is we want to write them in their prime factored form, which means we're going to do trees. So I'm going to take this 12 and I'm going to break it down. I'm going to split it up. It looks like a tree, and I can put here either any of the numbers that would multiply to give me 12. So 4 times 3 or 6 times 2, and I'll just go ahead and write it as 4 times 3. And you take a look at these numbers and you say, do either of these numbers go down any further? Yes, 4 goes down into 2 times 2. 3 doesn't because it's just 3 times 1. Okay, so this is what we call the prime factorization for 12. It's 2 squared times 3. Okay, for 18, I would break that down into 6 and 3. You could also break it down into 9 and 2. And then the 6 goes down into 3 and 2, and then I circle the endpoints of my tree. So I am left with a 3 times a 3, that's 2 3s. In other words, 3 squared times 2 for the prime factorization of 18. Now what I'm doing to identify the LCM is I'm saying, let's take a look at these prime factorizations and identify, first of all, how many factors do I have? I have 2 factors in this problem. I have a 2 and I have a 3. And I want to take a look at those 2 factors separately, and I want to say, how many times does each factor occur the most in any one factorization? Okay, so my LCM is going to be the product of that. So let's take a look at 2 first. 2 occurs twice here in this factorization and once here. So the most that it occurs in either spot is twice. So I need it twice in my LCM. Okay, if we take a look at the factor of 3, 3 occurs once here and twice there. So the most it occurs in either spot is twice, so I need it twice. So what I have here is 2 squared is 4, 3 squared is 9, 4 times 9 is 36, and that's my LCM. Least common multiple is what we're using to identify basically the common denominator when we go to take a look at adding fractions that have, so if we were to add a couple of fractions that had 12 and 18 as the denominator, the common denominator would be 36. Okay, so you actually know how to do that with numbers. You've known that for a while, but now we're actually using this process because when we go to algebraic expressions, we need to use the same process. And so let's take a look quickly at an algebraic expression. So for instance, this is number 25 in the book, in this section. Okay, so they give you these two, x squared minus 4, and then x squared plus 5x plus 6. And they want you, again, directions are to find the LCM. So what I'm going to do is, remember our directions said we're going to factor each of these expressions fully. This is the difference of squares. So this is going to factor into x minus 2 and x plus 2. This one's going to factor into, if we use trial and error, x plus 2 and x plus 3. Okay. Now, if I take a look at these two situations, I have three different factors in this problem. I have an x minus 2 as a quantity, I have an x plus 2 as an entire quantity, and then I have an x plus 3. So I need to run through all three of those factors and see how many times do they occur the most in any one factorization. Okay, so if I look at the x minus 2, it occurs once here and no times over here. So the most that it occurs in either spot is once. So I need it once. The x plus 2 occurs once here and once there. So the most that it occurs in either spot is once. So I need it once. And then the x plus 3 occurs once here, no times there. So the most that it occurs in either spot is once. So I need it once. So my LCM would be the product of these three different factors. So when we get later on in chapter 6, if we're going through and we're trying to identify how we're going to add or subtract a fraction that has this, one fraction has this as a denominator, one has this as a denominator, then what we're going to be doing is basically identifying, first of all, our LCM. That's going to be our common denominator, and then we're going to figure out what to do from there. And that will be, stuff that we'll talk about later. Okay, that's it for now.